Okay, so I'm going to draw something that's fairly simple, but it's a pretty important extension on something we did way back in AP1 when we talked about isotonic, hypertonic, and hypotonic. And the reason I think this is important is because often we think about cell shrinkage and cell swelling and think that that's the real problem. But the real problem with hypotonic and hypertonic, or because we're talking about the kidneys, when the kidneys don't regulate fluid balance, is that it changes how fast chemical reactions occur in cells. There's about 400,000 chemical reactions per cell per second, about 400 billion in the body per day. And those numbers might not be exactly accurate because it's not easy to predict that, but what you need to get out of it is a lot. So if we draw a circle like this, and this is just going to represent a cell, and we're going to have stuff, and by stuff, it could be anything. It could be glucose, it could be ions, it doesn't really matter. But if we're going to have stuff around this cell, and the same concentration inside the cell, then of course this is called an isotonic cell. Now we learned that if things want to spread around, so things like to spread around, and even in here that's happening, that's called diffusion. Things don't like to be next to each other. People don't like to be next to each other. We like to spread out. But if on the inside these guys can't spread out, then what can happen is water can move to help things spread out. So water can move back and forth, and that water movement is osmosis. And I always like to just define osmosis as water towards concentration. So in an isotonic cell, maybe that's not the best place to start, but in an isotonic cell, water in equals water out. And maybe now would be a good time to jump and draw it differently. In this case, I'm going to start by drawing the stuff. And so in this case, we are going to have more stuff outside the cell than inside the cell. And so that means water is going to move towards concentration. So water in here is going to move out. And so that means water out is greater than water in. And again, this was called, because the concentration is higher outside the cell, and we refer to tonicity as outside versus in, this is going to be a hypertonic cell. And since water is moving out, what's going to happen to the cell is it's going to shrink. So the cell shrinks. And over here, the cell stays the same. Before we talk about chemical reactions, let's go back and do obviously the opposite of hypertonic. And that, of course, would be we've got a lot more stuff inside the cell. So now we're going to draw a lot of stuff inside the cell. And not as much stuff outside the cell. So this is called a hypotonic. So hypo means below, like a hypodermal needle goes below the skin. This is called hypotonic. So this means there's a lower concentration. Hypertonic. And that means in this case, which way is water going to move? Water is going to move in. Sorry about the size of the brushes changing. The computer keeps changing things on me. So water is going to go in, whereas over here, water was going out. And so water in is greater than water out. And so what that's going to do to this cell, of course, is it's going to make the cell swell. So that's all review, but the important part now is to understand what chemical reactions are. And chemical reactions are when two things meet. It could be a lot of different things. It could be a ribosome finding an mRNA. It could be a molecule finding an ATP. But essentially what a chemical reaction is you have some molecule A, and it finds some molecule B, obviously leaving out things like the nucleus, still pretending it's a cell, but A finds B, and so those two things can find each other and react. And so this is typically cited as 400,000 chemical reactions per cell per minute. And hopefully you can jump ahead now and realize where I'm going with this. What's going to happen to chemical reactions then when a cell is in a hypertonic solution versus a hypotonic solution? Of course, A and B are going to be closer together now. And if they're closer together, they can find each other faster, which means chemical reactions speed up. Whereas over here, with the hypotonic solution, if A is trying to find B and the cell is swollen, it's going to be hard for A and B to come together to become AB. So it's going to be hard for the ribosome to find the mRNA. It's going to be hard for the tRNA to find an amino acid. And so what's going to happen here is chemical reactions and this is probably much more a larger effect on the cell than even just the swelling and the shrinking. All the speeding up and slowing down of the chemical reactions is going to happen and cause negative things in the cell long before it swells too much or long before it shrinks too much. All right, so the reason that's important then, of course, in the urinary system, you're controlling electrolytes and you're controlling fluid. That means you're controlling how much fluid is inside and outside of cells. You're controlling the hypertonicity, the isotonicity, and the hypotonicity. And so you're affecting chemical reactions in the cell. Thank you very much.